thanks, guys. Like, I think we should kick off. It's not really a formal presentation, but we have some content to cover, and also this time around we will not be doing any of the longer-ish coffee breaks. So if you really want or need to leave, maybe like an hour time or whenever, just like walk past. There's no problem. We all understand everyone has like their priorities and plans with the family. My name is Arseny Chernov, and I will be doing the first talk of the day today. There's also Alyona Melnikova from Refinitiv that will be doing the second talk. Before we get started, I just wanted to reiterate once again the importance of that RSVP versus giving us some heads up if you're not coming. So today was a perfect day. We ordered the exact amount of pizzas. Everyone had a slice. We will probably increase the amount of vegetarian pizzas next time. By the way, if you have any feedback on like what is good, what is bad about the organization, please let us know. We are very open. Another great shout out to engineers.sg that will be recording this talk today. So for those guys that dropped off, were not able to come last minute, they will be able to review this in a recorded fashion. Please, if you have an extra. Awesome. So if you have an extra couple of minutes during your commute today or later on tomorrow, send a $5 voluntarily donation to engineers.sg. This is a really great company. They're doing that completely voluntarily, coming around the meetups, recording and uploading them. We do have an announcement from Refinitiv because Alyona works for Refinitiv. She wanted to highlight next week there is a FinTech week in Singapore, and we will have, Alyona actually will have a Refinitiv Labs open day. So if you want to learn more about Refinitiv, contact Alyona. We will also show that slide once again. Please come over to their offices. They're pretty cool. Also, just as a reminder, there's a way for you to ask any kind of questions about Apache Spark, be that on any platform, on any realization in our Spark Slack Singapore Slack channel. So please do not hesitate. Connect with us. There are always like 15 to 20 people online on average. It's not really active because everyone asks direct messages for some reason, but like just throw everything that you want to know about Slack or some supporting technologies into the general channel, and we will try to answer as quick as possible. So I'm taking a look at it always. Very big thank you to AWS for hosting us today, and thank you, Gabe. Woohoo, really cool. Thanks a lot. There was a fridge full of soft drinks. Which was at right temperature, so that was all the best. This was the best meetup highlight so far. So okay, what we're going to cover in the first talk will be about working effectively with Apache Spark on AWS. And let me pull up a few slides. I will try to do as low on slides as possible. It's more about just sharing with you the best practices. Just a quick show of hands. How many of you guys heard about Databricks before? Whoa, that is really cool. Okay, awesome. I can now go home. So my job is done. So the idea behind this talk is to just show you the patterns that might not be known to you. Patterns of using AWS native services together with Databricks, how we work closely together. Databricks' mission, as you know, is to help data teams solve the world's toughest problems by analyzing the data, by making predictions out of it. And we do that at Databricks by offering the managed service, which is the unified data analytics platform. And that platform allows multiple functions within any organization to collaborate, to create value out of the data quickly, and then productionize it, whether it would be a pipeline, whether it would be like a live streaming data inference or something. So it all can be done within Databricks across data engineering division department, data science department, data analyst department, and actual business users. So everyone can collaborate on it. We are a global company that just crossed 1,000 employees mark. Woohoo! We have 5,000 customers, 450 partners. My role at Databricks is closely related to partners. If there is something that you want to find out about a partner program, catch up with me later. And the story of Databricks is very neatly tied with open source. So we were founded, the company Databricks itself is founded by the creators of Apache Spark. And apart from Apache Spark, there are a few open source projects that you might have heard about. Who heard, quick show of hands, who heard about Delta Lake? Yeah, there's more work for me to be done. Okay, awesome. And how about MLFlow? Who heard about MLFlow? Okay, that's pretty cool. So these are the open source projects that are incepted already by the same team of founders that did Apache Spark, but in their tenure at Databricks. And for example, Delta Lake is now in Linux Foundation, so it's a completely open source project. Now, when we speak about Databricks on AWS, what we actually started on AWS many years ago, we are able to provision an environment where data scientists, data engineers, your data analysts, they all collaborate. It's called the Unified Data Analytics Platform. That environment is provisioned within your AWS account, within the best practices that are established in your company. So we're not taking any data or any compute out of your existing AWS deployments. Everything is just kind of like layered on top of your existing AWS environment. I will be progressing more and more into technical topics. Please interrupt me at any point if you need to clarify something. Let's keep it very informal. And also for everyone who asks a question, I will have a small present. I have about maybe like a bag full of presents. Let me demonstrate. This is a real bag of presents. You can guess that there are some T-shirts, right? Because otherwise, what would be the full bag of presents, right? So, and I think there are some power adapters. So please interrupt me, raise a hand. I will reiterate your question. I'll try to answer it if I can straight out. So the Unified Data Analytics Platform actually consists of 3 levels, 3 layers, we call them. The bottom one is the cloud service. We take away any management of any EC2 instances that you can imagine are still needed to run compute. So that is completely provisioned for you. You don't need to worry about any kind of DevOps. They will be deployed, the Spark clusters, they will be deployed on demand, and they are in nature ephemeral. So you can, of course, leave a Spark cluster running for some time. You can actually like disable the auto termination and it will be an always on cluster. But the idea behind Databricks is to provision as much ephemeral compute on demand only when needed as possible. And to emphasize that, the Databricks runtime allows, this is the combination of multiple packages and our enhancements to the open source Apache Spark. We call it a Databricks runtime. Databricks runtime allows you to dramatically reduce the time it takes to complete an ETL job or do like a massive join. There are many tests that prove that, but like you don't need to take my word for granted. You can just try it out if you want to. So the idea behind Databricks runtime plus the Databricks cloud service is to provision ephemeral clusters that will be basically Spark applications. We don't stand up an entire kind of like Hadoop environment to run Spark. It's a standalone Spark cluster with a driver and the workers. And you're able to do whatever the workload that you can expect it to do naturally. It will be a regular Spark cluster. Plus, on top of that, there are multiple adjustments. For example, on AWS, we have our connector that is way faster and way more productive to work with Redshift. There will be enhancements here and there that are part of the Databricks runtime. And it will by itself accelerate the ETL jobs dramatically. And the third layer on top of that is the Databricks workspace. This is where the magic of collaboration between data scientists, data engineers, data analysts that do the dashboards, this is where it all happens. This is the combination of our own format of notebooks plus the ability to use MLFlow in a hosted manner, plus the ability to run Jupyter notebooks, all in a collaborated manner, similar to like what Google Docs allows you to, or some other kind of like Office 365's collaborative platform allows you to do for regular text. You can do that for your valuable code that works with the data. So that's kind of like the very high level. I just want to make sure that we're on the same page here. Now, speaking about SageMaker, quick show of hands, who worked with AWS SageMaker in any regard before that? Yay, we have a few people. That's cool. So AWS SageMaker is, by the way, did you notice this effect? This was really cool. I spent about a couple of minutes on it, practicing it. That is really cool. I'm so proud of it. So AWS SageMaker is a native service that allows for the end-to-end architecture of machine learning. And it allows to build, train, and deploy and provision the endpoints for restful microservice type consumption inference of these models for the downstream applications. The line below, I'm not sure if like the guys on the back, do you see that? But the line below, I'm saying AWS space SageMaker space help. And it gives the help of the commands that are under the tree of SageMaker in the AWS CLI. So there are 78 subcommands that relate to SageMaker. They pretty much have like, on average, few subcommands. So it's kind of like a really big platform. So to signify, the UI is much leaner, and I'll demonstrate the UI later on. And what the major part of SageMaker is finding its use is the real-time inference. So the architecture here, you can see that it's backed by the SageMaker hosting component, which runs a trained model. In some regard, it's basically a container that runs on top of an ECR. And there's a load balancer in front of that set of ECR pods. So SageMaker allows you to send a RESTful request and then receive the predicted value. Like, it's a very convenient way to build the in the microservice fashion, in a mesh fashion, a very convenient way to build the inference pipelines. Pretty awesome. But it also has like a lot of different components within it. And the training component, particularly inside SageMaker, severely relies also on the ECR. So you need to write up a bunch of wrappers for training a model. It will take the data from somewhere. The data will be in an Amazon format. It will take the data from somewhere, apply the model code that you composed, train the model. The model will be stored in an Amazon format, and then you can actually push it into the SageMaker hosting. That's very, very fast, the idea behind SageMaker. Now, the SageMaker, look at this. I really enjoy this, this transition. The SageMaker offers an SDK to Spark. And that SDK to Spark is known. It's been there since about 2017. It has about like a commit to the GitHub repo that you see here. It has a commit every maybe like five weeks-ish. So, and like a lot of that is basically release node stuff. The idea behind the original SDK was to provide a way from Spark to train a model of a given type on SageMaker. So I highlighted the boxes here. Basically, the idea to do, for example, a k-means clustering is to take the data from the data frame in Apache Spark, serialize it out into an Amazon format using the serializers, the SERDES of this specific AWS format. And then it will be picked up by the SageMaker training. It will be then trained, and it will be then stored as a model and served in the hosting way. So it's not really like what the optimal path looks when you already have an existing Spark cluster, probably in production, and you want to co-share it across multiple applications. But it's there. It has its own go. The way that the pattern that I highly recommend, the architecture pattern, is to use the MLFlow on Databricks. You can also use the open source MLFlow. It's just that the hosted one is provisioned for you. You don't need to configure it. And its particular tracking functionality to do the alternative reference architecture. And I'll demonstrate it in a second. So MLFlow.SageMaker is the entry point for you to serve to deploy the model that is trained on Spark, and you can use spark.ml, you can use spark.mllib if you're in the preference to the older machine learning component of Spark. You are able to deploy the model that you trained on Spark, that was trained using the data that was prepared on Spark. You can deploy it on the RESTful endpoint of SageMaker, avoiding any hassle. And it is really quite simple code. We'll walk through that. And you don't need to know all those 74 commands on the AWS CLI to configure stuff. All you need to do is like nitty-gritty details of like what is the AWS IAM that is needed to be attached to your Spark cluster so it can upload the model into SageMaker. That's it. Everything else SageMaker will take from MLFlow. You don't need to do anything else. So MLFlow by itself consists of 4 parts. I'm talking at this point I'm talking on the leftmost one called tracking, but there are also a black box project around any arbitrary Python code or Docker that is called projects. It's not really the topic that we want to discuss today. Models is the kind of common denominator format that allows us to do this magic with SageMaker. It's our MLeap-inspired kind of like format to export from multiple arbitrary and proprietary formats. Like scikit-learn has its own format, TensorFlow has its own format of the model. The MLFlow models project allows us to export into, yeah, there was a question? Yeah. Yes?
How does MLFlow models differ from things like Onyx, which have similar goals?
Actually, MLFlow has a lot of flavors to the model, so it's pretty much similar. So MLFlow is providing like kind of a common denominator through tracking. And to track the model, we'll do that in a demo. To track the model, you need to store it in some form. So there is a component called the flavor that picks it up from your preferred, say, scikit-learn format and stores it into a composed kind of common denominator. That's what we call it. There's not much of attention that is in the modal space. It's like one common denominator. Most of the attention is in the trackers, in the tracking space. And we've just released Model Registry. For those of you guys that didn't see the announcement, Model Registry is awesome. It's pretty cool. The idea behind MLFlow is to make a full machine learning lifecycle that many large organizations, only large organizations to date could afford to have, like in some sort of a framework where data scientists submit the model, some other person with the segregated duties tests the model, then someone else pushes it into production, multiple roles, multiple versions, everything is segregated and checkpointed in the model registry. We just released this component. It never existed up until maybe like a few weeks ago. MLFlow is also an open source product. You can do the pip install MLFlow and run it completely on your own Linux machine or macOS, and it took MLFlow. The really cool metric is how long it takes to reach a certain amount of contributors. In this chart on the left-hand side, you see about like 80 contributors that are in MLFlow only within the first 10 months. And you may see the yellow line was PyTorch and red one was Apache Spark. So Apache Spark took about 3 years to reach the same amount of contributors to what MLFlow is doing. And incredible amount of downloads. So 800,000 times downloaded from PyPI a month. That, of course, includes some DevOps, but who cares? It's still a big number. More than many frameworks. Yes, there's a question.
So when we say we will have a trained model in MLFlow, which will push
to SageMaker,
and that will sort of compose like a microservice and give us a REST endpoint. Now, the model also needs data, which is perhaps in your Spark.
Correct. Yeah. So the question.
You will transmit that data whenever the REST endpoints will be called, or how?
Okay. So the question. Okay. I think it was a conceptual question. Let me repeat that. The question was, since we are able to train a model within Spark environment and then push it into SageMaker, what would happen to the data? So you need to assume that the microservice that will consume the SageMaker, the downstream microservice, will be using the same schema that will be your train validate. So that's pretty much the idea behind it. I will show it in the code. We'll do the quick code walk, and it will be evident. But wait a second. So Gabe gets, nah, no, you don't, yeah? OK, so there was one more question, right? So you asked the first question, right? So you get a small prize. Can you pass the prize? If you don't mind, just pass it back. This is the coolest prize first, power adapter. And someone else had a question here, no? Can you raise a hand if, OK, I'm probably daydreaming. OK, so the MLFlow Registry, this is what I was saying. So you have the ability to segregate the duties, which is especially in the highly regulated environments of today. I'm not saying that the government will not catch up with machine learning. It will. It will be, again, there will be like we have Monetary Authority of Singapore technology risk guidelines. There will be something like that, but for machine learning very soon, maybe, maybe not. But yeah, in many large organizations, the segregation of duties and the checkup on the particular components of the machine learning lifecycle is very stringent. So MLFlow Registry is a big answer for that. And this is the idea behind MLFlow model format. So we take flavors, and then we kind of prepare the receiving part. So for SageMaker, for example, you can see the SageMaker here at the bottom, or Docker, they're kind of like correlated. SageMaker relies on a Docker container. We have a container that is part of the preparation of SageMaker. You need to push the, like, not in every time you push the model, but like once you need to push a specific Docker image, the receiving part of our model format. And then the magic of Conda and the isolation environment will take care of that, and you will stand up your XGBoost or whatever that need is in a completely isolated environment. But that's like taking one flavor as a source, putting it into the receiving end as the target. That's the idea behind MLFlow. And of course, you can close the loop. So you can, after you infer the data, you can send the feedback into the Delta Lake, receive it in the streaming fashion, and then make sure that once you deviate from a certain threshold of accuracy that was approved when you push the model through the model registry, you are then retraining the model, because the model changes the behavior of the downstream application and the user. So like when we're getting more recommendations about the food to order, we will inevitably start ordering more food of the recommendation. So we will start the bias of the training data set for the original model deployment. So it makes sense to retrain the model or make the new version release of the application, so that you can close the loop on that. Cool. So the demo is as follows. Oh, I cannot see my screen. Oh, because I need to round up. OK, now I can see my screen. Magic. Here we go. So if we go into, so for those of you that lately did not log into AWS console, like myself, it can actually cancel out on my login. Let me do that. SageMaker. There we go. Come on, 4G. By the way, guys, yay, I anticipated it. I did not provide the guest wireless, so apologies. 4G is also used in this demo. So we are. You messaged the password to me. My bad. OK, there was a password. We tried to hack it for like 20 minutes, brute forcing it. But yeah, then I gave up, and then you didn't. This is really cool. So the SageMaker service in here, well, this is what it looks like from the AWS console. So you have the endpoints, which is the like actively serving RESTful endpoints, the load balancer that then speaks to the Docker image that runs on top of ECR. And that Docker image can run whatever you want. It should be like a web end, like web HTTP server of any kind. So like inside our container, I think we run Flask RESTful, but maybe not. I'm not sure what we run. But this is the idea. So it's in service. You kind of do like a lot of it, a lot of its configuration. You can do like tags, whatnot. You can update the endpoint, as in like pick up the configured model from a configured path and then redeploy it on the ECR, and that's pretty much it. The rest is the magic of the 74 different drop-down commands. Like, it's quite lean, I'm telling you. The configuration here is quite lean. So the models themselves, this is where they are stored in some interim location on S3. This is the model that would be put on top of the receiving end container. Ta-da, it will work. And the images are part of the Docker images themselves. They are part of the configuration of the endpoint. So the kind of the moving parts in the reference architecture are here. So now what it looks like if we're trying to push it into SageMaker from Databricks. This is the notebook that is attached to a cluster, and it's a Spark 243 cluster, as you can see. It's called demo or whatever 5.5. It runs the Databricks runtime 5.5 type ML. That includes a lot of different packages like XGBoost and like many others that are also smoke tested to work flawlessly together. To prove that it's actually a Spark cluster, you can open up a Spark UI, which would be integrated. You can also look at like ganglia metrics for RAM, whatnot. Trust me, this is like a Spark cluster. It's not auto-terminating because I asked it. So it's up and running. So the notebook is one of the ways you can use Spark clusters. You can also schedule a notebook. You can still do the Spark submit job. If you have like a jar file composed of something, you can use it like the same way. Here, the idea is we are talking about the Wine dataset, the original old school like hello world dataset of machine learning. We're able to mix and match some commands, like I can switch into the shell context. So like right now, everything that is after the %sh will be on the driver of my Spark cluster. So like I get it from somewhere in the internet. I can do whatever I want. Like it's just literally shell there. And what I do afterwards is I put this downloaded data set into like a centrally available location. It's on the level that we call DBFS. It's actually S3. We just created like an indirection level, so you don't need to remember the mount points, the access keys. You can configure almost like in an old school Linux server, you mounted an NFS storage. You can do it in the same way. You have like a root, which is the root S3 bucket. And then to your root S3 bucket, you can mount additional S3 buckets and many other S3 buckets. And like you can traverse all them in a unified namespace. So this namespace is called DBFS, very convenient. And the idea in the data set is that, OK, it's a CSV, delimited, let's load it up. There are some certain characteristics of wine, and we want to infer the wine quality, arbitrary metric that we want to train the model on. We want to infer that in the end as the restful call from SageMaker. So what we usually do is exactly what we do in this demo, but we also add the import MLFlow. And by the way, for here it's a Python demo, but MLFlow is also available in a bunch of other variations. What we do here is like I define where my what would be the name of the SageMaker app that I will push, and it will be like used later on. Where will be the training data set for scikit-learn later down in here. So I define this is the train model with some parameters, alpha and L1 ratio. I define the training function. What you see below is start of an MLFlow run. This is a very important thing because it actually encapsulates a certain amount of hyperparameters, some activity that will happen with your preferred model classifier or regressor or whatever you want to do, and then it will result in the model outcome. So the run comprises a specific attempt to train a model and get some results. And runs actually constitute the idea of an experiment. So if I go into the runs sidebar here, this is what MLFlow tracking is all about. It shows me, OK, there was this run with this hyperparameters, and my R2 or my root mean square error was that. So this is where I can go and double click on like my particular experiment's best result. I can look at my hyperparameters. In this notebook, I'm not doing anything with the AutoML, but we have, of course, solutions like AutoML. And I can see a plot of my results. Like, for example, here I'm looking like the MAE. I can do RMSE. So I want to look at the lowest RMSE here, 72. What would the hyperparameters 0, 9, and 25? Or I can do the coordinates plot and find out, like, it's just like a combination of luck, weather, the usual, right? So like this is all about machine learning. So once I selected a particular run, my model inside that run is stored alongside of the metrics that you've seen in the visualization. So and the way that I log my model is like I provide a flavor. In this case, it's scikit-learn. I say like, OK, scikit-learn, log the model, right? And then I'm able to then take it out from MLFlow tracking and deploy it on SageMaker. Or deploy it, I can also like just apply it as the UDF function in Spark SQL, if I want to, I can say like, okay, here's my data frame, just like apply this, infer, easy. But the idea of the RESTful endpoint is here. How much it takes us to deploy to SageMaker is to provide where the base receiving image of the model format is. This is the particular ECR that is hosting my base Docker image. And you create the Docker image from your command line, or you can have like a system engineering pipeline that creates it once every now and then. It's literally on the MLFlow on my local laptop. It's MLFlow SageMaker, and I think it's something like push, yeah, build and push container. So what it would do, I need to have my Docker running though on my local machine, but it will create this Docker image, the receiving end, and it will push it to my whatever my .aws config. Oh wait, what was it? Ah, right. Yeah. So the credentials, right? So whatever is configured as my default profile for the AWS CLI, MLFlow will then push it into the preferred regions ECR with the needed tags. And then it will also obfuscate for you. You don't need to worry about it. It will obfuscate the creation of that endpoint using that image. You don't need to worry about it. It's like completely done for you by MLFlow. So this is where you specify, here's the image, and here's the model. The model points into a particular run. As I've mentioned, we need to point to that best hyperparameter, either programmatically. In this case, it's just like manual things. But like you can point, like, okay, this is the best run. Get it out. And then this is where the magic happens. mfs.deploy, boom, you're going. So that thing took about 8 minutes because I had to, like, it's actually a replacement job. So I had to destroy the previous endpoint. I could have created another endpoint, like, and do the A/B testing if I was in production, but I was not in production. So I used the same endpoint, and the replacement of the images in a couple of ECR instances behind the SageMaker load balancer takes a little bit of time. But then once it's up, you can use the Boto 3 to test the status of the SageMaker endpoint. You can see that it's in service. And then you basically create a string that would be the answer to your question about the data to be inferred, the actual production data. So then you create a string, and most of the online services take the pandas UDF RESTful JSON format. So that string is sent to, and I'm using, as you can see, it's just a requests import here. I'm sending this string into the endpoint, and I'm receiving a particular wine quality, 5.3, whatnot. I don't even remember. It could be a completely scrappy model with a lot of, like, I don't really know. But this is just to illustrate the ABC of the SageMaker deployment. Now, what's cool about it is, like, you prep the data, you done all your joins, transformations in a pipeline that resulted in a RESTful inference on SageMaker, straight out, right? Cool. Any questions? Yes?
For creating a model, you have some pre-processing ONG or indexer or something you have applied. And while calling, you also want, like when you are calling the model endpoint, so you also want that to be applied as well before.
Yeah, okay, so the question is, like, if you do the one hot encoder or like some other prep of the actual inference data, like vectorization of multiple dimensions, if you want to send it as like a real number into an endpoint, the endpoint has to be trained like that. So if your microservice downstream processes the raw data in raw dimensions, it has to do the transformations, definitely, yes. I mean, inevitably. And up there is, and you get a prize, thank you. And yeah, here we go. Woohoo, can you pass that if you don't mind? Thank you. So the and up there it could be any Spark code. You can do graphs, you can do Spark SQL, you can switch and you can do something in shell as you've seen. Move the data. It could be like an hour long before you deploy it in one notebook, and then you schedule it. The scheduling of the notebook is like here. You create a job. You can use Airflow. Like there are Airflow providers for Databricks, whatnot. You can use any other arbitrary scheduler. There is a RESTful API for scheduling, but you can create a job, and there we go. So, any other questions?
How do we apply for this model for streaming data?
RESTful endpoint streaming data. Like, I mean, it will be like coming as the HTTP requests. So I mean, we are assuming the non-Kafka type, like the non-message, the non-MQ type data. So we're assuming a RESTful in SageMaker, right? But you can also, of course, stay within Spark and connect Spark real-time inference, like using Spark structured streaming to like a bolt in Kinesis or in Kafka or somewhere else, and then apply a model on it using a UDF, user-defined function on the particular micro batch. Cool. You get a prize. Now it's time for T-shirt. Oh no, there's one more power adapter. Yeah, please pass it. Okay, cool. So so that was the biggest chunk of the presentation. So like I want to show you a few more things, and they will not take a long more time, and then we'll pass it to Alyona that will share the Spark 3.0 and file sources announcement. Now, how about Redshift? Redshift is awesome. Redshift is a data warehouse that is known, trusted. It's been out there with multiple, like thousands of customers doing a lot of transformations. Inside of Redshift, there are some statistics about queries that are under the hood, but they are easily exposed. You can actually download them. You can log them. And one of the things that we noticed at Databricks is that with Redshift particularly, customers use, and it's a cluster, right? So Redshift is a cluster with a leader. I should remember to use it, a leader and a compute. It's not master slave anymore, right? So like from 2019, what did this year bring to us? Master slave, no more. Leader and compute or whatever. So yeah, so there's a leader and compute, and it's EC2 instances, and you may have like a standby cluster and zillion significant data warehousing solution with all things. Now the internals of data warehousing solution, like Redshift, it's not only unique to Redshift, with adoption, they start to show that there's a lot of transformation work going on under the hood. So instead of being just a data warehouse where your longevity of the data is exposed for the downstream business intelligence reporting, it now becomes like this engine that munges the data, which is not optimal because it adjusts the latency of the downstream queries because you have more processing, and then B, not necessarily the engine of data warehouse was designed to do that. The transformations at scale, So what we noticed, and this is like from several customers, I don't want to go into the details, but the red one is the transform type of queries. And again, this is like the metric that is based on the type of query, like if you do the like load or something like that, this is like considered a transform, right? So the metrics show that up to like half of the time by the CPU by the hour is spent on the prep of the data. So if you're not scaling the cluster, then the latency. If you're scaling the cluster, then the cost, right? The usual compromise. Now, how about if we follow this example? There are like quite a number of them. But you may take up the query that does the transformation, the logic that does the transformation, run it as an ETL job on Databricks at like hundreds of spot instances. Like you don't need to do the. Usually Redshift would use the reserve instances, but still it is like an on-demand instance, right? It'll just churn on the monies. You can use the acceleration of Delta Lake with NVMe cache SSDs of spot instances, i3 type. You can do like really crazy fast transformations and then load them up into Redshift. And this is actually net improving the latency, improving the cost profile, and overall serves the better kind of customer satisfaction based on what we observed in some customers. Now, yes, yeah, sure.
So what I'm taking away from this is you had, if a query was taking like 40 seconds, let's say, on your slide, and a lot of that time was waiting for Redshift to do its ETL stuff, it was faster and cheaper to spin up a spot instance, wait for that instance to come up, delegate shove some data onto its NVMe disks to do the work, and then get that into Redshift?
Yeah, this is not correct. I'm probably confusing you. So the question was whether these queries are consecutive, and then the preparation for the actual business intelligence query is like the outcome of the transformation. No. This is the concurrent type of queries on the hour. So there are some. This is the shared resource. So the Redshift cluster carries on some transformations around, as well as serving the downstream BI queries. I didn't make it clear.
Instead of having Redshift do both responsibilities,
yes.
doing the ETL type
Right,
and
right.
loading the data into Redshift.
Correct.
That combined,
Yeah.
Infrastructure
Yes.
would still resulted in net cheaper and net faster.
Yes, correct. So I need to repeat that. So the net result of taking, this was a brilliant phrase, I need to repeat that. The net result of taking away the combination and splitting into a spot instance-backed Databricks cluster, plus leaving the BI queries for the Redshift, leaving them working on the best of the best of their design principles, is cheaper and faster. Yes, this is exactly right. So that's net result. Awesome. Like, I need to record it next time. I'll take a note. So I really appreciate it. So the way that it looks, we had a connector developed for Redshift, which is not as so it's actually, there are two connectors that you need to have on the Databricks cluster. One is coming from AWS that uses the kind of like the flavor of the Postgres to connect to do the JDBC queries with Redshift. And another one is a connector that allows you to load and upload the interim data through a staging area on S3. So loading the data, again, like I already ran it, loading the data, bulk of data, like we're talking about gigabytes of nightly uploads of transformations or something like that, is easily done in parallel using multiple task workers. Think about those like hundreds of spot instances. They all go into a scalable S3 storage. Each uploads a small chunk of the interim format. That is then Redshift is knocked about, and then Redshift takes that, ingests that data back into it. So you can do the JDBC queries to do the lookups. Like here, I'm looking at my data frame that was just sourced from Redshift cluster, and I can do the regular data frame transformations onwards, or train the model, or do anything I want. But at the same time, after I'm done, I can stage the changes using the Spark SQL notation. I can stage the changes into that temporary S3 location on like gigabyte scale or something like that, and then merge them into the existing Redshift folder, so through this temp folder. So that allows us to avoid the single kind of, not thread, but like single choking point of JDBC query. Even though there are some ways to parallelize JDBC, it's not really very well done when you have like several nodes on Redshift, and with Spark, it's very chaotic. So it's easier to just dump it into S3 and then load it into Redshift. Perfectly working. And the assessment of this query is, it looks into, this is the notebook that resulted in those type of queries breakdown. I didn't run it because I don't have like, my Redshifts are like all pretty much stagnant, they are not. But if you look into the actual types of queries inside, it's basically in the meta store of Redshift. You can look up like your 24 hours, what were the type of these queries. They're not exposed in the Redshift UI, but then you can make sense of how you use Redshift using that. The third and the last point about the optimal usage of AWS and Spark is about these three guys, Glue, Athena, and Amazon S3. I mean, yeah, okay, there was a question, sure.
What are the difference? What are the differences between the Snowflake and the
Okay, there is a good question. So what is the difference between Snowflake and Databricks? Architecturally, we sit like Databricks is in your AWS account. It is a Spark cluster. We have a better runtime, which is a combination of our proprietary investments into query optimizers, whatnot, but it's like a Spark cluster. So you use like really Spark that you know. And it's more importantly, it sits on top of like AWS in your account, so you can use the IAM roles integrated neatly with your preferred storage. You can use the single sign-on. You can use the Scheme API for groups. It's like a component of your infrastructure that you add into your AWS account. This is like most important architectural difference. Now, what's behind the scenes in, they start to reveal stuff, what's inside the Snowflake realization. We actually are, like, the way that we are getting our value, like we are a private company, but we have like this like hero number of $6.2 billion of valuation. I don't know what that means, but like that's really cool. we are not thinking about competitors as much as we are solving the customer's problems. Like, I really don't know what's going on there. Like you're asking the wrong guy. I can tell you like what are the people in Southeast Asia, in Australia, and in Japan are using Databricks for and AWS for, but like Snowflake, they started to open the hood, but I don't know what's there. More importantly, it's in your AWS account.
Actually, the concern is like we have PA information data that Snowflake is, I mean, when we have a Snowflake actually, when we had a kind of thing like from AWS, we wanted to just migrate to
Yeah.
Snowflake, and then we had an issue like the PA information, we don't want to migrate from AWS to outside of
PII information, personal identifiable information, is a concern, and I don't have any given like solution pattern for that. You must adhere to the regulations of your internal company, governance policies, into the regulations of your government policies, whatnot. You need to like really follow whatever the kind of tops down regulations are there. Speaking about Snowflake, we actually have a connector that is also developed for Snowflake. You can do the data frame read and write into from blah blah Snowflake, but it doesn't use anything close to what the parallelism of like Redshift is, for example. There is no interim staging area, whatnot. So now this is the last bit, and then I'll let Alona take you through the Spark 3.0 update. Glue and Athena. Who knows what's glue? Not the shoe glue. Okay, the glue. Okay, right. Athena. Who knows what's Athena? Yay. Okay, good crowds. So for those of you that didn't raise the hand, Glue is quite a big service, native service of AWS. One of its largest component is a serverless metastore that allows you basically to have, who knows Hive? Yay, okay, so basically Glue has few components, and one of them is a serverless Hive, which allows you to store the definitions of the external tables and data that is spread around multiple S3 buckets. Who knows Amazon S3? I mean, like, my mother doesn't know what's that, so like I had to ask, right? So so Glue stores the definitions of where stuff in which schema, metrics, statistics. It stores it there like a regular Hive, but it's serverless. So you can connect to it and query it, and then you have all the different databases and tables within it. Athena is a web UI for querying the Glue catalog, and it allows you, again, to create a workflow where people log in into a particular account using their assumed role, and they're able to execute the queries only against the Glue table that they see and whatnot. Yes, Gabe?
One more point about Glue that I think is really cool and related to this crowd. Glue also lets you do serverless Spark queries against your
Yeah, you can run. Yes, there are two more components. One is that you can actually schedule. You can do the Glue transformations. They're called. And you can do the transformation using the Spark on top of EMR, which is like an open source Spark with some tweaks here and there, but it's like a Spark that you all know. And also there is a Glue, how you call it, the crawler, right? The spider? Is it the crawler? Yeah, that actually allows you to go and schedule the the load ups of the new data as it traverses on schedule or automatically from like different file sources. So that's.
I think Glue is the easiest way to get started using Spark if you have your data on S3 and you just want to query that data and get a result.
Yeah, well, there's.
Or, sorry, if you want to use Spark. Athena is the easiest way.
Yeah.
If the data's on S3
Yeah.
and you just want to write SQL.
Yeah. So the premise there's basically a combination of different things to factor in. So one of the reasons why I wanted to show this integration is, first, it's super easy to get started with Glue on Databricks on AWS. So Glue doesn't need any configuration when you are in AWS console. It just exists. So all you need to do to start using Glue as the meta store for your Spark clusters is to provide, here's my cluster. One of them, this one, doesn't have the external meta store. It uses what you see here, the workspace that has the notebooks, the jobs, the clusters, the experience that data scientists and data engineers use is the workspace. The workspace comes with a meta store, which is like a Hive. It's like a small, tiny, not small, tiny, regardless. Basically, it's a meta store. It comes with a meta store. So you can actually look at the data here. You can see some databases, some tables, and you select which cluster to look at into the into this experience. So right now, if I'm looking at the glue, it gives me one view of data because it looks into the glue. If I'm looking into the default meta store that comes with the workspace, it comes with this workspace. If you had an external meta store configured, say, on MySQL or PostgreSQL somewhere on premise, yeah, I mean, there are external meta stores, come on, like everyone knows how to configure them in Spark. You would have a third dropdown, and you will need to use that Spark cluster that has the external meta store for both the driver and the workers, and you will have a different picture. So it's like kind of like not a split brain scenario, but you have to cater that in, that you will have multiple clusters viewing different things, or you have to default them to one. It's like up to your design decision, right? So how are you going to connect all the dots? But to configure the cluster to connect with Glue, this one has the Glue configuration just as a Spark, just as the Spark config. Yeah, there we go. So it says Glue catalog enable.true. It's from Databricks runtime 5. If I'm not mistaken, 0 or something. Like, you don't need to worry about it. You provide this configuration. Next thing you want to make sure is that your cluster has an IAM permission, because you still run an EC2 instance that need to infer its own security instance profile. So you want to make sure that that instance, an IAM role that this cluster is inferring in the configuration of Databricks has the needed permissions for Glue catalog access. That's it. Read, write, you design, right? That's it. So when you're working from Databricks, you see, I will select the Glue database here. You can see the Glue demo from Databricks. If I'm going into Glue itself, where is it? Glue here. Did it go? 4G. Yay. Yeah. So we have databases that was in Glue demo from DB, whatever. You have the common picture. So now you can query, say, from Athena, you can query the same S3 sources that you would query through Spark SQL in Spark. So through Athena, you go into Athena, and you can query something that sits on S3, be that a Parquet or Avra or Delta. Delta format massively, it's not a topic of our talk today, but it massively accelerates the Parquet by adding the transactional capabilities, transaction log to it. So you can now do the multi-hop pipelines. You can mix and match batch and streaming. It's really cool thing. It's just like we're running short of time. I'm not going to double click on that. But the idea of having Athena, this tab. I had a lot of tabs. So having Athena read a Delta table is actually quite beautifully realized. So you can see now that I'm reading a table that is called loan stats _ train _ via Athena. It gives me some preview of that table. And actually, this is a Delta table. It's not a Parquet table. And the idea behind Delta table, for those of you that raised hand when I asked, is that there is a transaction log level indirection into multiple Parquet files that are disaggregated. And you can do the compaction behind the scenes to avoid small file problem. You can do the Z ordering, create the index on your Parquet. There are many things you can do. But the idea is it's not just Parquet. So if you just point Athena into the folder with Delta table, it will not really understand what the heck is going on. Too many Parquet files and not really. So you need to enable a manifest. This is one thing that connects the dots in between Glue, Athena, and anything that you do in Delta. You need to enable a manifest, which is a very simple approach here. You use a command to generate a small manifest file, like here is like for the, actually this one. Here is the command against a particular path that has the Delta table format inside of it. You generate a manifest file that will be automatically updated when you update the Delta table. And that manifest will point into the latest proper version, which Parquet files to connect to. And then in Athena, you create an external table using that manifest. And it's all connected. So I got a couple of customers using that for the processing. It's all like naturally coming as a result. So these are the three patterns. So we've spoken about the RESTful models serving using SageMaker. We've spoken about Redshift and how it's easy to work with Spark as the Spark instance back transformer for your BI queries to take away the latency and reduce the cost. And we've spoken about Glue and Athena and how they come together and join forces to weld the joint solution. I have a few more T-shirts. Questions about these three pieces? Yes.
Very basic question about your Databricks cluster.
Yes.
So I've seen that there is like minimum, there is one, minimum worker and there is max worker. There are two things, right?
Yes.
So are the auto scalable, auto scale up and auto scale down?
Yes, by default you have the auto scaling. You can see the tag here. This is when I create a new cluster. You can disable it. It will be aggressively downscaling or upscaling as there is a amount of Spark tasks outstanding. It will provision more and more Spot instances. And
will you prefer it for any streaming application? Because suppose
correct. Yeah. So good question about streaming applications. It would not be recommended to run all of the types of applications on one cluster. You would probably have to have like a small cluster that does only streaming types of jobs. In your partitioning definitions, whatever, like how many workers will be using the connections to Kafka, whatnot. But it will be preferred to have like a per workload type cluster. So you have like an ephemeral cluster for a job that spins up and down. You have, backed by Spot instances, you have an always-on streaming data type of processing cluster. You have a massive shared cluster that you wake up at 6 a.m. every time when your data scientists, or 7, what time data scientists come to work? I never thought about it. So like whenever your data scientists come to work, you'll wake that cluster up, and then the cluster terminated, it's ephemeral, right? So it's like, doesn't mean. So you'll wake that cluster up, they will be able to do the data science and do the data analytics and create the dashboards and whatnot, like connect the JDBC tools like Tableau or QuickSight of Amazon, whatnot. They will be third cluster, and then there'll be a department type, like pipeline consolidation, fourth cluster. You're using the elasticity of compute, right? So that doesn't necessarily mean you need to join all of them in one.
No, I understand that. So my question was like, will you suggest to use this, auto scale up, auto scale down in streaming applications?
No. So there will be different type of cluster for your streaming applications. Disable it. Like it wouldn't make a lot of sense because you will not be able to. You can always scale up. As you see the messages falling behind on the latency or something, you can add workers if you need to by adjusting the cluster configuration. But scaling up and down will introduce a little bit more chaos, in my opinion.
Okay. So the question I asked because like in streaming applications there are few. In night there will be very less traffic, and in the morning.
I understand.
Daytime there will be huge. So like if it has to be done manually, doesn't make sense. Like if.
Yeah, so we would then look into creating a small cluster and then maybe load balancing the cluster after 6 a.m., like something like that. You can just run a small job that even inside the Databricks will run a call to the API and then provision a new cluster and then connect it to the same endpoint and streaming. We can take it like we can talk about that. It's actually a good question. It's not really today. Not really streaming related, but that's a good question. There are caveats about it. Yeah, you're right. Yes, please. Yeah.
Just a quick question about regarding some MLOps methods. Supposing right now, if I have Iguazio for my MLOps in the sense, how do can I actually integrate Databricks with Iguazio in the sense so that Iguazio will just handle the MLOps for me?
I will need to look into I don't know it well, so I'm the kind of person that will just tell you I don't know if I don't know. So I don't know it well, but if it can do some kind of model export into, say, a common flavor, we can then pick it up and track it in MLFlow. But I don't know. Like we need to look it up into the integrated details. So ping me or like, yeah, let's connect about it.
Okay, thank you.
Cool.
For provision or instance, does it kind of integrate with like solution like Spot.ins?
Like what?
Spot.ins.
Like Spotis. What is Spotis? Spot instances.
Yes, Spot.ins. It's kind of a solution that automatically provision the Spot instance from AWS.
Okay. So we actually control. Here's everything that you're asking for on the screen. So we control the mixing of Spot instances into Spark clusters for you. You don't need to worry about it. You can also so you can say like I want to start with one on-demand instance. The rest, based on the availability and my price bid, will be spots, because you may have like spots bid price going up, and then some of the workers will disappear. They will be taken away from you. But we will bid up, as you can see in this configuration, we will bid up to 100% of the basically on-demand price, right? So we will bid up progressively, paying more and more and more for these spot instances to the level of on-demand. So your cluster will not shrink. You will still always have the maximum amount of workers, like 8. And we do this for you. You don't need any additional solutions or anything like that.
Really nice.
Yeah, that's really powerful. And also, we default to the i3 instance type because it has the NVMe SSD in it. But it also has up to 80% discount of the on-demand price. It's one of the most discounted instances because no one uses it but Spark, right? So like, it's really cool and it's really cheap, and its availability is through the roof high. So always look into using spot instances when possible. Yes, please. In Redshift, I think there is default. Yeah, it's default, right? Yeah, it counts actually the data that you see on Redshift cluster. It already comes like as if it's compressed with some assumption. So if you're provisioning like a 3-instance Redshift cluster, it gives you like a few hundred gigabytes of data, even though the instances might have like smaller disk sizes, whatnot. You don't need to worry about it. It comes with compression assumption. Yeah, LZO, yeah. Yeah. Same with Spark+AI though. It's like snappy, whatnot. So, yeah. Good. Good questions, a lot of questions. Now, because I will not remember, and I need to pass the mic to Alyona, what I will do is I will take this bag, and then just maybe it would be fair if you come up to me, and I'll just give you this T-shirt so that Alyona will carry on. By the way, there are a lot of AWS stickers, AWS Databricks, and Databricks stickers. Any combination would work. They're on that table in the corner, right? So cool, guys. Thanks for attention, and let's tune into the update on Spark 3.0 then. Yes.
Notebooks are open source?
These notebooks. Oh, by the way, the wrapping slide. By the way, whoa. Yeah. Ta-da! Actually, if you go into databricks.com/AWS, there will be the similar kind of link. There's a free training about Databricks on AWS that includes most of the topics that we discussed today. Yeah. If it's not there, just ping me. Like it's very easy. Our documentation is through the roof cool. Like I love our documentation because it's on point. We don't have any other documentation but public. It's like completely agile company. So
Do you also give any free clusters to community developers?
you can try not with the community edition. You can try almost all functionality of MLFlow and like all the things that we've seen today. You can try it on Databricks Community Edition, but not with like SageMaker because you need the IAM roles for that, but whatnot. We give away 14 days of subscription to Databricks, and we charge by the machine run hour of our Databricks runtime. So you don't pay for compute. You still like it's your account, right? So you pay for the EC2, and we charge like few cents on top of that. But we give away 2 weeks of that kind of few cents. So on average, just reach out to us. We'll help you guys figure these things out.
One very basic question.
Yeah.
Do you any minimum upfront you require for Databricks or Delta Lake?
Minimum what?
Minimum upfront has to have a commitment to.
No. It's pay-as-you-go platform. I mean, we will give like if you have like petabyte or like whatever. Like I don't know. If you have any particular enterprise discussion, Simon, where is Simon? Simon. I have a colleague of mine from Databricks, but he's not around here, so he was here. Have a conversation with Simon. He knows all the things that I'm not salesperson. Like he has all the things about it.
Do you have banks as your customers as well?
A lot, yeah.
Both of us come from Citi.
Yeah, I'm extant chart. Cool, let's talk. So, okay, Alyona, I'm very sorry. I'm taking away your time. There we go. You need to take this small mic.